All right. So here I'll talk about an actual application of Bayesian model that I did on my NFL pick'em pool. Specifically, I'm looking at the probabilities that pickers in the pick'em pool will pick specific teams. So we'll just talk about pretty informally, basically the whole entire thing, the pick'em pool, and then also the model. So how did this all start? Um, I wanted to have a reason to watch football. So I basically just started a pick and pool with my family. So that was in 2018. So I think 3 years ago, and now we've picked seasons of football. It's the pool has grown about to about 6 people total now. Um, Here's how this season went. So I'm the dark blue line, unfortunately. Can you believe how heartbreaking this is? Oh, it was terrible. But it was fun. So I'm trying to get an edge on these people and figure out who they're likely to pick. So I made a model for that. Um, at Thanksgiving, I got this. I took a survey asking everybody to score from 1 to 10 how good the NFL teams were. So I got everybody to do this. My grandmother, who she actually like does legit polls and stuff. She just gave it a lots of ones and like tens. So it kind of messed up my model, so I didn't include it. So maybe she'll win next year because I'm not accounting for her in this model. But anyway, I asked them to score how good the teams were, all 32 teams, and then how much you actually like the team. You can see we're Vikings fans, we're Seahawks fans, and that'll pop up through the rest of our model. I'm a big Panthers fan, and then the season's over now, so I have data on how many times each of these people picked each of these teams. So again, I'm a big Panthers fan, so I just picked them every single week. That didn't play out too well for me, but popular picks were the Packers and the Seahawks were pretty popular. The Jets only got one pick from Sophia, so there I didn't include them in the model. And the Jaguars might have been left out at some points too. But anyway, we have this data on these teams. Survey data, it's pretty subjective, and then actual data. So I incorporated the survey data into my prior distribution just to reflect, my the subjective probabilities I've assigned to each of these people picking these teams. And then I use the times picked as the likelihood parameter, not parameter, but variable in my model. So we'll talk about the model here. Again, yeah, my motivation for making this is I wanted to estimate the probability that each of the pickers in the pick and pool will pick any of the 32 NFL teams to win in any given game. And I can extrapolate that to the whole entire season. So just like at the beginning of the season, ESPN will say, oh, we predict the Browns to get 8 wins this season or 8.5 wins. That's what our model says. I'm having in my model predicting what the other pickers will actually do. Like, oh, my model says that Sophie will pick the Browns 9.2 times, and so on. So this could be useful for me. And if I'm losing and everybody's got to pick the Seahawks, then I'll pick against them. So I can analyze who people are likely to pick and then make decisions off that. This model isn't very rigorous, so because I'm assuming that like the degree to which the pickers prefer a given team, and so the survey data and how good the pickers think the team actually is, have the same weight in their decision making. So like the rational beings, this is what my prior distribution assumes. The rational beings that care about these two things very equally, which is probably not the case. And then in the likelihood distribution, I assume that the pickers are blind to the game-by-game matchups, any effects due to time. So it's basically as if they were making their picks blindfolded to different matchups, and at the beginning of the season, and then they were just basically saying, okay, the Seahawks are going to win nine times. So that's what my likelihood distribution assumes. So those are sort of pretty hefty assumptions. So our model could be baloney in, baloney out predictable, but it's still a good learning experience. And I hope to actually teach you how you can set up easy prior likelihood distribution to get a posterior distribution. So this is basically my answer to part D in the reflection, is to teach you how to set up a continuous prior, use a likelihood distribution to find the posterior distribution. So how would I develop a prior distribution for the probability of my family members and me pick a given team in any given game? So I developed a naive model for estimating this. Okay, yeah. Right, using the survey data. So it's pretty subjective. I think this makes sense. So I used the beta distribution. So the skill score plus the favorite score. So this can be anywhere between 2 and 2 is the minimum score and 20 as the maximum score. Divide this by 2. So the minimum you can have is 1. The maximum you can have is 10. And then, so that's the alpha parameter. And then the beta parameter is that same number, but 12 minus that. So in the maximum condition, so say I assigned my favorite team is the Panthers, so I gave it a score of 10, and I think that they're the best team, so I gave that a score of 10. Then I'll have a beta 10 2 distribution that's shown in turquoise. And if for like the Jets, they're my least favorite team probably, or perhaps, and I don't really think they're good at all, so I gave them 1s on both. If that was the case, then my prior distribution for the Jets would be this red line. And these distributions I think make sense because I'm not like all the time. I'm definitely not gonna pick the Jets. I'm not definitely gonna pick the Panthers because things vary game to game. So I think these are okay prior distributions, and they're, as we'll see, they're pretty robust in the model. So let's look at my prior distribution for the Cleveland Browns. So it's shown here, and I think I got it pretty spot on. I'm not a huge fan of the Browns, so I'll probably just a little bit less than half the times I'll pick the Browns, but I'm pretty neutral to them. I think that's what my prior distribution shows. So here we'll talk about the likelihood. So now we're taking the data from the 2020 season and actually plugged it into my likelihood distribution was a binomial distribution, which I'm using. So n equals 16, right? Because that's the amount of opportunities I've had to pick the Browns in any given game. And then y in this case is 10 because I picked them 10 times in the season. And here's so brown is the prior distribution, orange is the likelihood distribution. So likelihood shows that I'm, based on the evidence, I'm more likely than not to pick the Browns. So I think this is also a powerful thing that I've developed in my model as well. And so how does this play into the posterior distribution? So posterior, of course, is proportional to prior times likelihood, and then you just scale it. So that's this black line, which I think is totally accurate for my probability of picking the Browns. So you can see it's a compromise between the prior and the likelihood to develop the posterior distribution. So it's developing posterior distribution. It's pretty simple. I used my subjective probabilities in the prior based on survey data, then the observed evidence from the 2020 season, and using a binomial distribution for that likelihood. And that's how I developed posterior distribution, by multiplying prior by the likelihood and scaling. So quite powerful. So yeah, again, this black line represents the posterior probability that I pick the Browns in any given game with those assumptions that I mentioned earlier. So now I applied this model to the rest of my family and the other 32 NFL teams, except for the Jets. I think I didn't include them because difficult in my model. And we'll see the, sorry, Jets, we'll see the results here. All right, so here's a ridge plot for the posterior probabilities for just I think it's the mean of me and my family's probability for picking each team. So below, I talk about the posterior probability or posterior distributions for each of the pickers regarding one of these teams, but these are just the means for all of us pickers regarding all of the teams. So you can see that we're much likely. All right, well, we have a large posterior probability of the mean for us picking the Seahawks to be about larger than 0.75. So that goes for all 5 of us. And we're not very likely to pick or for our mean, posterior probability mean, to be larger than 0.25 for the Jacksonville Jaguars. So basically, I included this to show that I did, in fact, get the data for all of this, and can use this to make decisions, I suppose, next season to understand the means of my family members' posterior probabilities of picking these teams. So I'm a huge Carolina Panthers fan, so I wanted to look at my posterior probability of picking the Panthers and my family members or the other people in my pick and pool as well. So I'm this line here, like the little turquoise line. So I think this is representative. I'm pretty darn likely to pick the Panthers. So pretty proud of my posterior probability or posterior distribution here. I think I could tune this to say even give it a higher weight on the likelihood. So I think I would add that to my model, but I am also happy with it because this model I think correctly gets a distribution right for the rest of my family on the Panthers as well. So yeah, again, these are the posterior probabilities of picking the Panthers for me and the people in my pick and pool, except for my grandma. So then I looked at the data, so the actual times picked in the 2020 NFL season, and then the posterior mean times picked. And you can see that there's some regression to the mean in the posterior mean times picked to around 8. I think that makes sense because, you know, the 2020 data could be a fluke. And another thing I did in this plot is include the skill and the favorite survey responses. So you can visualize that. So you can see that they're more red. There's a larger representation of red dots up here than there are down here. This is more blue. So that represents that teams that have larger actual times picked in the data and then larger posterior mean times picked, we generally think are more skillful. So I think my model works well in that case. And the reverse is also true. So I think that makes sense as well. The favorite, there's not too much correlation there. I think I actually got the correlation, and I think there's like a 0.6 correlation for skill and a 0.3 correlation for favorite. But anyway, that's what that plot shows. And then I plotted the posterior variance in the distributions against the posterior mean times picked. And you can see that I think this really makes sense since posterior variance should decrease near the endpoints here, like near 0 games picked and near 16 games picked, because there's probability that pools near the endpoints, so it kind of gets stuck here. And in cases here, the probability is spread out across many possible numbers. Sometimes there's compromises between the prior and the likelihood here, so it makes sense the variance would be highest when the posterior mean times picked is about 8. All right, so overall, I used a prior distribution based on survey data. The likelihood distribution was based on observed data from the 2020 season to develop my posterior distribution. I analyzed some of it. I think it makes sense. See what I need to tune if I wanted to tune anything. And yeah, I'm pretty happy with it. So thank you for watching. Hope you learned something.